is y equals to 2x plus 12 upon x. And the equation with the straight line is y equals to, it's actually y plus x is equal to k, where k is a constant. Find the set values inequality for which the line does not meet the curve. When the line does not meet the curve, the discriminant should be 0, less than 0. Now, either way, when they are saying to you the line does not meet, or the line meets, or is a tangent, you still have to take the curve and let it equal to the straight line. But this one, there's a little bit of problem here. It's y plus x, it should be y equals to. So you make y the subject of the formula, then this becomes k minus x. So you're going to take these two, because if both of them are equal to y equals to y equals to, then they are equal. So that means they are sharing a point or 2 points. If they share 1 point, the line is a tangent. If they share 2 points, the line intersects. You understand what I'm saying? But we are being told that they don't meet. Right, so it's a scenario where you have something like this in an island. And there are certain values of x that you're going to put into this function, the y function, where it will never meet with that. And that range, the value, is going to be a range of certain values. You follow? Okay. So although the two functions don't meet, you still have to equate, but then you are not solving the equation. You then work with the delta, or the discriminant is less than 0. Does that make sense? So the other stuff there just becomes a little bit of algebra. So if 2x plus 12 upon x is equal to k minus x. Now remember that k is a constant. Okay? So we have a problem here with this x here that we don't particularly like. So I'm going to put that part in brackets, because I'm going to multiply 2 out by what? By x. That means I'm going to multiply here by x for these to cancel. I'm going to multiply here by x. And I'm also going to multiply here by x. Okay? So this is going to leave me with 2x squared plus 12 equals to kx minus x squared. So that kx minus x squared will come to the other side, let it equal to 0. Okay? Right, so it's going to be 2x squared plus x squared plus 12. In fact, the 12 is a constant. So let's write x after I bring the kx. So minus kx. Is that fine? I can still simplify further, right? This becomes here.
I have a question.
Yes.
Isn't it 12x?
Isn't it what?
12x.
The x cancel when we move to 12. Okay?
Yes, 12x.
Right. Now, we know that if delta is less than that, okay, let's put in our delta. It's going to be, remember, delta equals to b squared minus 4ac coming from the product equation, right? And our value of b happens to be minus k, which will just be positive, right? Our value of a happens to be b. Our value of c happens to be what? 12. We know that this value should be less than 0. Okay, so I'm not going to let it equal to 0, less than 0 now. I know what I'm expecting. Because it's less than, I am looking for answers that are below the x-axis. You understand? And when answers are below the x-axis, looking at how this stuff is going to be, that function, it's going to be something like this. So we are looking at this particular value here. But these two should not be included. You understand? It's going to be inequality. Explain something big on the right, something small on the left. But then you won't have or equal to. You understand? Because of the nature of my discriminant. So this is k squared. Now here you go. 4 times 3 is 12, 12 times 12 is 144. If you let this equal to 0, it becomes the difference of 2 squares. So effectively, one here will be negative 12 and then one here will be 12. K sub 1 equals to 12 or K sub 2 equals to 2. But we are not looking for the values of K. We are looking for a range, a set values, So K would be in the middle, right? It would be less than 12, and K would be greater than. This comes from our answer, our work on topic 1. Yeah? Our work on topic 1. Less than means we are dealing with things below. If it was greater than, then we'll use a part. And in that case, it comes in O inequality. You understand? Alright. Then the second part of the question. In the case where K is equal to 15, the curve intersects the line. They say the lines at points A and B. When K is equal to what? 15. So we have got y plus x is equal to 15. Right? And that side you have got function 2x plus 12 upon x, right? Equal to y. Now we know what that value is, so we are going to write that in terms of what? And equate them. So y equals to 15 minus x. With me? Right. So when it says the curve intersects, just when it intersects, it means they are going to be a point A and a point B. Right? So what would our delta be? Greater than 0. So our delta will be greater than 0. Why you are not consider O equal to 0? When do we consider when it says equal to 0? Look at the example. I think the example deals with the tangent, right? Or they don't say it's a tangent. It says a tangent, right, somewhere. But is our delta greater than 0 or greater than or equal to 0? That's what I'm asking.
Only when it's 0.
When is 0 included? Remember when I said you are supposed to highlight? I said meet. Remember? In your book. Good. When it says meet the curve. Because we don't know what that meet means. The meet could be a tangent or the meet could be it intersect. Meeting is touching or intersect. You understand what I mean? At that particular point the functions can be equal. Alright? But the line one can be a tangent line or the one can be a second line. It means some line that cuts through a circle or a function. That is curvic in nature. So when we have the word like meet, we'll have greater than or equal to 0. Right? Yes? So we're going to take these two and then we're going to equate them. So it's going to be the same concept. It's just going to be 2x plus 12 upon x is equal to 15 minus x. The same story, we're going to multiply again throughout by x. Yes? So if I do this multiply by x, I hope you get the idea. So this is going to leave me with 2x squared plus 12 equals to 15x minus x squared. Rewrite everything in x squared plus bx plus c form equals to 0.
This becomes 3x.
3x squared minus 15x plus 12 equal to 0. Right. When our function is like this, right? Because the inequality is greater than 0, the solutions will be above the. This is very important. So our solution will be here, but these 2 points will not be. You understand? Okay, so our objective here is now to solve this equation, but we know we are going to end up with an odd. Good. Right. So, can I do this one? Yeah, I just want to find a place where I can do it. Alright? I'll do it here. Is it fine? The white chalk really is not that good. Right. So when we take that equation 3x squared minus 5x plus 12 equals to 0, and we are dividing 12 by 3, it's x squared minus 5x plus 4 is equal to 0. Two numbers multiply give you 4. That's a minus, so I'm going to have two minuses now. Minus 4 minus 1. So one solution for x is going to be positive 1. The other solution for x is going to be positive 4. Right? But it's not it. We are supposed to find the coordinates of the point. So now we have the x values. We need to find the y values. By substituting this into, where's the straight line? Y equals to, into this one, right? So we're going to substitute into y equals to 15 minus x. Y equals to 15 minus x. So when it's 1, what do we get? When it's 4, what do we get? This is going to be 14, yes? And this is going to be what? 11. So our points would be, point A will be 1 comma, and point B would be 4 comma 11.
Nothing different.
Nothing to be afraid of. Nothing to be afraid of. But is this the solution to our question? Find the values of A and B. Yeah?
It should.
Should. Say? We did something? Yeah, similar. Something like this or something similar? Are you up to it to go see, since we are there talking too much? So C says, find the equation of the perpendicular bisector of this line joining A and B. Now, in order for you to find the equation of the perpendicular bisector, you need to find what is the gradient. You have the coordinates, so you find the gradient, and then once you have the substitute either point A or point B. Is that fine?
Midpoint is needed.
Is the midpoint needed?
Because we don't know. To substitute either.
The midpoint is needed.
Exactly.
Okay. Because of what? What is the key word there? No, what is the key word? What is the key word that tells you you're supposed to find the midpoint? Bisector! Tell us slap. Bisector means in half. What does perpendicular say to you? What are you supposed to do there?
The gradient.
The gradient. And what would be the gradient of a perpendicular line? It would be whatever the gradient of AB is, the opposite and the inverse. Okay?
Exactly.
So let's find the gradient of AB. Yeah, now you can do after I. So we have got 2 points, right?
The ones we found.
So now that we have the 2 points, you see why, Professor Bradley? Why the white is not nice on the board. Doesn't seem so nice, okay? But I'm going to write with it because after this we're going to clean. Our point A is 1,14. And our point B is 4,11. Because they are saying perpendicular, we need to find the gradient
In the midpoint.
The gradient of AB, because when you multiply the gradient of AB with that line that is perpendicular, you should get
Why are you
negative 1.
putting the thing there?
That's perpendicular line.
So you can use it.
Yes, of course. So the gradient of AB is delta y over delta x. Delta y, 40 minus 11. I think it's been a while since you got in London, eh? 40 minus 11?
Really.
Really? Is the answer 3? And 1 minus 4, Bradley, is the answer negative 3. So the gradient is negative 1. So if, Bradley, if the gradient of AB is negative 1, what would be the gradient of the perpendicular bisector? It will be what?
Excuse me, sir.
Okay. If the gradient of line AB is negative 1, what is the gradient of the perpendicular bisector of that line? So essentially, -1 times what is -1? Positive 100. Good. So the equation of that line, the equation of the line we're looking for will be 1x plus c.
Just X.
But I'm putting it there so you can get the idea. The C point comes from the word bisector. So once we're dealing with the word bisector, it means we need to consider the midpoint of AB. Because the midpoint is a common point of the perpendicular lines N9AB. That makes sense? Because it's on the same point. Nice. The common point. We follow. So the midpoint therefore will be the average of the x coordinates. It means you take your x coordinate 1 plus 4, that's half of 5, comma, the average of, here we go again, 25? Wait. So the answer is 2.5 and 12.5. 2.5, comma, 12.5. There's a difference, okay? The comma separates the coordinates, the decimal is the point. Okay, he says he doesn't like working with decimals. Now let us just focus there because we are not done. We are supposed to find the value of C. So how do you find the value of C? You substitute the midpoint into that formula. Does that make sense? And then you can give your equation. And they don't but even say how you should leave your equation. So you can leave it in the form y equals mx plus c. Right. So I'm running out of space, so I'm going to come here, right? So in order for us to find the equation, we are going to say y equals to 1x plus c. So we're going to use the point 12,5, or we say 25 upon 2 equals to 1 times 5 upon 2 plus c. The reason why I want it over 2 is because it's easy to subtract with a common denominator of 2. Because this whole thing should be subtracted from that. So that's 25 upon 2. Take away 5 upon 2. Okay, so that's value c. 25 minus 5 is 20. Half of 20 is 10. Therefore, c equals to 10. So the equation that we're looking for is y equals to x plus 10. The y-intercept is 10. You see, there was no need, it's just the way it's written. I hope you followed exactly what I was doing, right? From part A up to part.
Those coordinates
Is that fine?
Those two coordinates. Those coordinates.
So although